境，你会怎么做？它倒是告诉我，我怕听不见。一剑气的火把，是你式的魔法，慢慢的渗入我的心逐渐。你举起千斤更难逃脱，抬头看天空，爱就在飘落。可以是歌手，是作家，写诗在行诗，当然那些爱情小说。水火让我伴着你左右，爱情在燃烧，看着你火候。你最爱看太阳落下，我明天。
Good morning, everybody. I hope this video finds you well. Guys, big news coming up. And I really want to let you guys know. I am going, this purpose of this video is to introduce you to version 2.0 of Affirmation Campaigns. My original work and writings on affirmation campaigns and manifestation is still valid. It still works. But I've made some tweaks and some alterations and some changes that fundamentally change the behavior of affirmation campaigns, making them faster acting, making them more precise, and making them manifest more completely. And I am calling this version 2.0, Affirmation Campaigns 2.0, or something along those lines. I haven't formalized the exact wording. Maybe something with a little bit of pizzazz or something like that, I don't know. But essentially, guys, that's what it is. I'm going to tell you how this came about. And I am going to tell you what to expect. This is an introductory video just to get you guys excited, because I hope you are as excited as I am. In all my campaigns, for the longest time, I always add this little affirmation that says, I know exactly how to word my affirmations to obtain exactly what I want to manifest. I do it all the time. It's a constant. But what I've done recently, or in the last year or so, I added another affirmation alluding to the fact, I forget the exact wording, that I understand completely how the affirmation system works and what makes it happen. I understand why affirmations work and within this reality and things of that nature. Which then brought me to, as it always does, to adding other affirmations. I now have full understanding of how the affirmation campaign works relative to our reality. This understanding enables me to perfect my affirmation campaigns and manifestation ability. And boom, 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 a lot of other stuff started happening. Coincidentally with this, as those things started hitting me, I also ended up having, on the global stage, artificial intelligence was making breakthroughs, especially in ChatGPT and Sora AI and picture generation and everything. All this kind of stuff is like happening at once. What a coincidence! Guys, you know there's no such thing as coincidence, right? So, I put all these things together. And I put I'm calling it a theory. While I believe it's the case, it's still a theory. This theory, affirmations as manifested by reality, is but a theory that discards the biblical narrative that we were placed on earth to opine for our sins and stuff like that. And right or wrong, I'm sure there's many other theories about what reality is, and I don't want to get involved in the other theories. So I clarified this stuff up, cleaned it up, made it a little bit better, and I ran a couple of trial affirmations in an attempt to perfect version 2.0. And so I ran some of these affirmations and they started hitting a lot faster. Faster is relative. I'm getting affirmation manifestation that used to take 3 years are now seemingly taking 6 months. It's fast. That's very fast. Doesn't happen for everything, and I'm getting some of my other affirmations are still punkering out, becoming something that not intended. Now, the reason for this is, like I said, in your previous histories, you have said things or whatever that you need to compensate for. All the actions you did when you were 5 years old, all the actions you did when you were 12, all the actions and things that you said and did when you were 22, all those things still exist in the ever-present now. You have to compensate for them, and these actions prevent certain things from happening. Okay. So this affirmation campaign 2.0 is an improvement over campaign 1.0, which is the stuff you guys all know about. Templates, pre-birth world line templates, no change. Templates, no change. World lines, no change. Right? Affirmations don't change. Affirmation campaigns don't change. Well, what's changing? What's changing is, I'm going to call it style, and that's really not a good word for it. But I'm going to call it style. You see, even though I say that we are a consciousness and everybody else is a ghost, when we do our affirmations, we still keep the other understandings of what reality is in the back of our head. This Affirmation Campaign 2.0 is completely different in that you are consciousness inhabiting a body, which is what I said before. But your focus is now, you are consciousness. That is all you are. You are consciousness, and you're inhabiting this body. Consciousness. You're consciousness. And while on the template might be a quadrillion zillion world lines, they're only potential world lines. They don't really exist. They may never exist. They may never manifest. Because the only thing that matters is what your consciousness experiences. Whoa! The only thing that matters is what your consciousness experiences. Whoa! The only thing that matters is what you, as consciousness, experiences in your body that you are in at this very microsecond. And that is extremely important. It's an extremely important aspect of version 2.0. So I've studied how AI generates art and videos and elements, and I actually cloned a video from another AI enthusiast that I'm going to pop here for you. Excuse me. For you guys to enjoy. And it will go through some of the terms of AI. These are the exact same terms that I am going to use in Affirmation Campaign 2.0. The only difference is that instead of a two-dimensional image or a word or phrase, it's an experience that you as consciousness experiences. So everything else is the same. You experience something and you define those experiences. In a way, it's sort of like that old Twilight Zone movie, or little, what do you call it? Twilight Zone story episode where the guy dies and he meets this nice gentleman, and the gentleman says, "Here's a party in the room. Tell me what you want in the party." He tells him. Then very next day, that party lives on. And he says, "Oh yeah, but I wish that girl talked to me, and I wish I had this to eat." He says, "No problem, we'll make the changes." Next day, that's what happens, like that. And no, it's not hell. You just have to be very careful what you define. So, let's look at this video right here. Let's watch it. I'm going to have it run here for a little bit, and pay attention to the terms that they're using for AI, because we're going to use the exact same terms for Affirmation Campaign 2.0. All right?
Will give you a deeper understanding of AI. So the essence behind all AI we know today, whether it's ChatGPT or Midjourney or Stable Diffusion or Sora or AlphaFold, the backbone of all of these AI systems is the neural network. A neural network looks like this. It's basically layers of nodes, so each point here is called a node, and each line of nodes is called a layer, and each node is interconnected with one another through these linkages. And the neural network is actually designed based on the human brain. Except for nodes and linkages in the human brain, it's just a network of neurons and synapses. So you can see this is a microscopic photo of a human brain, and you can see all these different nerve cells being connected in this very dense network. A neural network is basically the same structure as this, except that it looks like this instead of a bunch of cells in this bloody glob of an organ. Now, how exactly does an AI work? Let's start with a very simple example. Let's say we have a neural network which is trained to identify images of cats versus dogs. And don't worry, I'll talk a lot more about how we train an AI in a second. But first, let's just go over how this works. So let's say we input or we feed this neural network with an image of a cat. This image would actually be broken down into data, and the data will flow through each of these nodes. And after it flows through the first layer of nodes, it will flow through the second layer of nodes, and then the next layer of nodes, and then the next layer, and so on and so forth until it reaches the final layer, in which case it would calculate the values of this, and based on the values of the final layer, it would spit out an answer. This is a cat. In fact, you can think of each of these nodes and links as dials and knobs that determine how much data flows through to the next layer. If you think of this in like realistic terms, and I'm not saying this is how a neural network works, but you can think of this node, for example, as the shape of the ears of the animal. This node would be the shape of its paws. This node would be the shape of its eyes, etc. That's just a really dumbed down way of looking at it. It's not really doing that, but each node is basically looking at a certain feature in the image, and then if the image has that feature, the information can pass through to the next layer. If it doesn't have that feature, then the information is not passed on to the next layer. So depending on what image you feed it, the flow of information could look like this, or it could look like this, or like this. You get the point. It's just these knobs and dials determine how data flows through the neural network based on your original input image. An important distinction between a neural network and the brain is that these nodes can let in a percentage of data. So it can let in no data or 0%. It can let in all of the data to the next layer, but it can also be a percentage of the data. So for example, it can let in 30% of the data to the next node. This is slightly different from the human brain's neurons, which tend to just fire 100% or 0%. This is called the all or none law. So once it passes a certain threshold, this neuron will fire. Whereas neurons in an artificial neural network, they could fire just like 50% or 30%, etc. Just a minor distinction. So we plug in an image of a cat through this neural network, and at the end layer, it will determine that this is a cat. Now, for each node, there are also, if you want to get into more technical details, there are certain parameters that determine how much data flows through to the next layer. These include weights, biases, and activation functions. But that's beyond the scope of this tutorial. All you need to know for this video is that each of these knobs and linkages determine how much information flows through to the next layer. This video is just a very simple explanation of how AI works. So all you need to know is that these nodes and linkages determine how much data flows through to the next layer. On the topic of layers, each set of nodes is one layer. So the first layer is called the input layer. The last layer is called the output layer. And then all these layers in between are called hidden layers. So why am I talking about layers? You probably have heard of the term deep learning. Deep learning is basically training and using neural networks with lots and lots of layers. In other words, the neural network is very, very deep. That's why it's called deep learning. All right, how does an AI actually learn? You can't just have any random neural network and it just magically knows how to identify images of cats and dogs. So first, when you build a neural network, the values of these dials and knobs are probably just going to be random values, or they could be pre-trained values, for example, from an existing model. But how do you get it to be super good at identifying images of cats and dogs? In other words, how do you fine-tune the model to your desired purpose? Well, you need to feed it data, lots and lots of data. So you're going to have to prepare tons of images of cats and dogs, and then you label it. So this is a dog, this is a cat, this is a cat, this is a dog, etc. Basically, this is the answer that the AI needs to learn from this input image. This is called supervised learning, where you label the data. There's also another type of learning called unsupervised learning, where the AI needs to learn to categorize data by itself without any guidance from the human. But for the sake of this video, let's just keep it simple. So we have all these images of cats and dogs, and usually to train a neural network to do a task very well, you need a lot of data, like usually millions of data points. So you basically feed these images to the neural network one by one to train it. And one session of training is called an epoch. So, all right, let's say in one training session, you feed it this image of a dog, and it outputs, this is a dog. So, all right, that's great. We got it correct, which means that these dials and knobs are doing quite well. They're probably configured correctly since it got the answer correct. You probably don't need to adjust these further. However, what if for the next image you feed it this, and then it outputs, this is a dog? Well, this would be incorrect. So these dials and knobs are likely not configured correctly. If it gets the answer wrong, and it knows it got it wrong because we labeled the data cat for this image, so it can compare its output with our label. So alright, let's say the real answer is a cat, but it said this is a dog. In that case, it incurs some penalty. That penalty basically tells it, alright, you got it wrong, so you need to adjust these knobs and dials to make sure that the output is actually cat when I give you this image. And how it adjusts the values of these knobs and dials is through an algorithm called gradient descent. It adjusts the values via backpropagation. So it adjusts the nodes in the last layer first, and then the previous layer, and then the previous layer, etc., until it reaches the first layer. So again, gradient descent is a key term here. This is the algorithm which the neural network uses to adjust these knobs and dials until it can get the correct answer. So we basically rinse and repeat this with millions of images and lots of epochs or training sessions. And initially, this neural network might get a lot of values wrong, but through this process of gradient descent, these knobs and dials will be tweaked so that eventually, whenever it receives an image of a cat or a dog, it can accurately determine this is a cat or this is a dog. In essence, that's how you train an AI. That's how an AI learns. It's just feeding it with tons and tons of data and then tweaking these settings so that you get the perfect combination. Now, you might ask, well, how do you know how many layers you should have in the neural network? Or how many nodes you should have for each layer? This is a science in and of itself. So previously, scientists kind of just determined it manually, but then we later learned that you can actually use an AI to determine the optimal amount of layers and the optimal amount of nodes for a specific task. But just be aware that determining the architecture of a neural network is very complicated. And there's like infinite possibilities of how many layers you can have, how many nodes in each layer you can have. Different AIs with different functions have different architectures. So they could have vastly different numbers of layers and nodes. But again, that's beyond the scope of this tutorial. Also keep in mind that even though the neural network is the backbone of all the AI that we know today, there are different architectures depending on the AI's purpose and function. For example, we have convolutional neural networks, or CNNs, for processing images and object recognition. We have recurrent neural networks, or RNNs, as well as LSTMs, or long short-term memory neural networks, and these are often used for forecasting time series or predicting, for example, the stock market. We also have the transformers architecture. Oh, wrong one. This one, which is used by most of the major large language models that we know today, including GPT, Claude, Llama, etc. Which brings us to the next question. How does ChatGPT work? So again, it's kind of the same thing. It's training a neural network, but in this case, instead of images of cats or dogs, we train it on a language and all of the data in the world. And of course, the neural network of ChatGPT is way more complicated than this. Rumors claim that GPT-4 has 1.76 trillion parameters. So here's an example of how they would train it. And again, I'm oversimplifying this by a lot here, just so you can get a high-level understanding of it. There are a lot of details that I have left out. So for example, you could feed it data like this. Which planet has the most moons? And the answer to that would be Saturn. Which country has won the most World Cups? Brazil. What's the world's fastest bird? The peregrine falcon, etc., etc. Now, these are very basic questions, and you can see how complex it can get if you give it a prompt like, write an essay on XYZ, or does creatine help build muscle? And then it spits out an answer like, creatine supplementation generally enhances muscle strength, increases fat-free mass, etc., etc. This is a very long-form and complicated answer. So how does it know if it got that answer right or wrong? It's not as simple as identifying an image and determining if it's a cat or a dog. And that's why initially how OpenAI trained GPT was it had lots of humans actually manually verify its answers to determine if GPT got it right or wrong. And this is called reinforcement learning from human feedback, also known as RLHF. And again, if it gets the answer wrong, so for example, if for this question, which planet has the most moons, it answered Jupiter instead of Saturn, then it would get a penalty for it. And then through gradient descent, it would tweak these knobs and dials further until the entire network gets all the answers correctly, no matter what prompt you give it. So in essence, that's how these large language models work. It's just instead of feeding it images of cats and dogs, now you feed it all the data of the world and you feed it a language so it understands text prompts and text outputs. Now, why are some models better than others? For example, why is Claude 3 better than GPT-3? That's likely because Claude 3 has a lot more parameters, so that either means more layers, more nodes in each layer, more complexity. Generally speaking, the more complex the neural network, the better it is at handling complex tasks, and the quote-unquote smarter it is. And that's why computing and these AI chips are in such high demand. There's now a lot of investments flowing into AI chip companies because they see the potential of huge growth in the space in the upcoming years. And that's why, for example, NVIDIA's flagship H100 GPU is also in such high demand. In fact, it was sold out for all of 2023. This is like the most prized commodity in the tech space. And you can see like the major tech companies like Microsoft, Meta, they have purchased an estimated 150,000 of these H100 GPUs to power their computing, which I would guess is mostly for AI development. You need to have enough computing to power a neural network with billions or trillions of parameters. All right, next question. How does image generation work? Now that you know how a neural network is trained, you can probably guess how image generation works as well. Instead of feeding it images of cats or dogs, you would feed it a lot of images with a text description. And again, you just feed it millions of these images, each with a labeled text description, into this neural network that eventually gets good at producing an image based on a text description, or what we call a prompt. Now, I'm skipping quite a bit here. So for example, here's how Stable Diffusion works. You can see that the neural network doesn't actually generate an image. It removes noise in sequential steps to eventually get your desired image. So it's not starting from a blank canvas. It's actually starting from random noise, and then in each step, it removes some noise until you get your generated image. So this process is called reverse diffusion. Now to train it, what this actually does in the back end is you feed it the original image, and then in each sequential step, it actually adds noise to the image in a process called forward diffusion until it reaches an image of just noise. Now, again, this is beyond the scope of this tutorial, but if you look at it from a very high level, at the end of the day, it's just training a neural network based on a series of images with their text descriptions. And then through this process of forward diffusion and reverse diffusion, it's able to eventually learn how to generate an image based on a prompt. And this brings us to the next question.
I hope that you didn't find that too boring. But I'm pretty convinced that that is similar to the way affirmation campaigns manifest. And with that in mind, we can absolutely control the knobs and dials of this system. Because after all, isn't Affirmation Campaign 1.0 the same empirical manual method of determining the difference if a picture shows a dog or a cat? We did it manually, empirically. Now we wanted to add some automation. We want to add more dials, more direct correlations. It's a filtering process. To make the things manifest, to cause our reality to manifest, we have to train ourselves to understand what we mean when we make manifestation requests via affirmation. Now, a manifestation request is an affirmation, but we're going to be a little bit more professional about it, more exacting about it. It's nice for us to say, I eat ice cream every day, because that is from the point of view of the body that the consciousness inhabits. But you can change that a little bit more. You can make it more precise. I eat vanilla ice cream every day. Or even further precise by saying, I eat French vanilla ice cream every day, soft serve, that is presented in a waffle cone. The ice cream is extra cold. Now, obviously, the same rules for Affirmation Campaigns 1.0 still apply. But when we start making these affirmations and we start setting up the dials, these knobs and dials, it will require another set of affirmations. Let's call them the manifestation parameter list. So in version 2.0, you will have two lists, so it's more work. The affirmation list, which you guys always do, and a affirmation parameter list. And the affirmation parameter list will list the dials and tweaks that you will use together. And like all things, because we're saying them and using them and our mind is interpreting them, we will speak them using the language of our choice, which for most of you is English. So we would say something like, and I'll go into all these, but basically what these this manifestation parameter list is, it describes the rules of generation. So before, in version 1, here's our affirmation. That's what we want to happen. In version 2, we have our affirmations, plus we have the rules of how they will be generated, how they will be manifested, how and when and why and what attributes will occur. These are the rules, these are the dials, the check boxes that you see in AI. Need not be a big list. Right now, in version 1.0, we're not using a manifestation guidance list. We're not listing any of the parameters. So it's just going on the affirmation vocalization itself. But if we were to say something like in the list, all affirmations listed manifest within a 1-year time frame. That is a manifestation parameter list. Okay? Now, the problem with these parameter lists are, if you make them too aggressive, the changes might be a little discomforting. Like I said before, if your affirmations are working, you're going to be uncomfortable. If they're not working, you're going to be comfortable, because it's the same old, same old. So if you start making aggressive parameters, then you're going to start getting a little bit of discomfort. Okay, that being said, so people, I am going to flesh this out more in other videos. I'm going to go through how to make a affirmation parameter list, manifestation list, also the preamble, because I think that it might be a good idea to have a preamble and some other rules. Okay, so the basics behind version 2.0 is you're no longer self, you're consciousness. All the other world lines are meaningless to you. They're just potentials. There's instead of a affirmation prayer list, there are 3: a preamble, a affirmation parameters list, and a affirmation campaign list. And we'll follow the AI generation tools. I think you'll be very happy with it. Trust me. Okay, guys. I'm sorry I'm so long on the tooth. I've really been trying to cut the length of these videos down. I hope that you like them. My number one request for Patreon and everything has always been the affirmation manifestation stuff. Affirmation campaigns and everything. People also like to hear a little bit about what I did for the Navy and want to hear some of this and that. But the by large, affirmations is the most requested subject matter, and I hope that I'm delivering. And I think that you will really enjoy version 2.0. I'm going to have to get down and get busy. That's what I think. So guys, remember, be kind to dogs and cats. Do your best in everything you do. And remember, I believe in you. Bye-bye.
Yourself in a miss your time. Sissing out here, it will blow your mind. Come and increase and in all the crime. Which crime me attack? And the gun crime. Waste them from true, what can't be fine. The youth them tired living on the bread line. The money no excuse to rob the blind. Our weapon is a body pass it and time. 是为了谁？我们的心碎。